together. So hello, I'm Godfrey. Just had an intro. You can find me on the internet as Changing Code. You can also find me at a museum in Shanghai if you don't have access to the internet there. Oh, actually, there's something very important that I forgot to do. Sorry, hang on for a moment. Yeah, got to do the Snapchat thing. So if you can wait for me, that would be great. All right, thank you very much. So if you can wait for me, I actually did it. So. All right. How do I do this? Okay, there we go. Sending it to the entire Vancouver. All right. So with that out of the way, you probably have a few burning questions in your head right now. For example, you're probably wondering, it seems like we're a little bit behind, so maybe I should just stand here. Okay. There you go. So you're probably wondering who's this guy, and why should I listen to you, and why am I even here right now? And probably you're thinking you need more pizza. So we can go through these questions in reverse order. So first of all, the last one is not actually a question, so I can't answer that. The one before it is obviously a rhetorical question, so I also can't answer that. But the first two questions I can answer. So why should I listen to you? The short answer is probably you shouldn't. And who is this? So again, I am Godfrey Shen, and Changing Code on the internet. And if you have been around in Vancouver for a while, you probably have seen me around, perhaps at bus stops and stuff. You might have drawn on my poster at bus stop or at some point. And also, I'm on the Vancouver Ruby website that Philip talked about. You can see I have a hat. So whoa. I brought it with me today. It's because I don't usually get a lot of opportunities to do that. So, so that's me. I also helped build a thing called Ruby and Rails. You might have heard of it. I was on the Rails core team until pretty recently. I also started a newsletter called This Week in Rails. I'm not very involved with it now, so I can't take credit for it. But if you're interested in Rails, that's like probably one of the best way to stay up to date and stay in touch. Last time I came to Vancouver, I talked about an open source project I'm working on called Helix. If you're interested in writing Ruby extensions in Rust, two of the coolest things together. So Helix is an open source project that I work on that you can look up on the internet. And other than Ruby stuff, I also do some JavaScript stuff. I'm on the Ember core team, which is a JavaScript framework, if you have heard of it. If not, you can probably look that up on the internet. Also help with the language spec at TC39, which is the language community for JavaScript. And when I'm not doing any of those things, I work at a company in Portland called Tilda. We have a product to sell you called Skylight. It's a performance monitoring product for your Rails application. So if you have a Rails app, you might want to sign up. And if you have a moment, it will be really great if you can write down this link quickly, as it will help pay my salary. Don't be shy, you can do it. Like pen and paper. All right. So even though I did try to sell you a product, my official job title at the company is in-house Canadian. My main job is basically to go around at conferences and in this case, TV show to promote Canada. That's me there. And I think I have been doing a pretty good job promoting our country. As you can see, this is from Google, right? Like you can see the interest for like the number of search queries for how to move to Canada spiked 2 times last year. If you have been following the news, you probably know what's up. The first spike was when I announced like my speaking schedule last year. And the second spike corresponds to my talk at the Portland Ruby meetup. So yeah, so I do have some numbers to show there. Anyway, with all of that important stuff out of the way, we can get into the casual part of the meetup. So I understand this is I understand this is a Ruby meetup, so you're probably here expecting to hear about Ruby, but instead I would like to spend the evening on a different topic, if that's okay with you all. Today I would like to talk to you about computer science education. It's a pretty important topic to me personally, and I hope that would be relevant to you as well. I know they're like a good mix of like students, and like some of you are working, some of you are thinking about applying for boot camps and stuff. So I hope this will help you in some way. And yeah, we'll see if I can accomplish that today. So specifically, I would like to discuss how we are reinventing the ways that we are training new entrants to our industry, right? Like, and the implications associated with that. I realize this is a somewhat controversial topic, right? Like, so it's like, oh, universities, CS degrees versus boot camps, right? But like, and for full disclosure, I did come from a traditional CS education background, right? Like, I had the privilege to dedicate 4 years of my life studying, actually 5 years of my life studying for a college computer science degree at SFU, a local university that you might have heard of. So I happen to also really enjoy learning in that kind of environment, right? So I'm probably a little bit biased, but on the other hand, I also had the privilege to work with and learn from a lot of my colleagues my friends and colleagues, many of whom who didn't go down the same path as me. In preparing for this talk, I had many insightful conversations with a lot of these friends and coworkers and colleagues in open source space and all of that. And I tried my best to incorporate their experience and present to you a balanced perspective here. So that's my disclosure. So to set the stage for our discussion, I would like to introduce you to a old Chinese proverb. So in Mandarin, you say it as 授人以儒,不如授人以儒. So this is translated literally. This means giving a person a fish is not as good as teaching a person to fish. Okay, there you go. We caught up. And there's a more poetic version of this proverb that you probably heard of, which is to give a person a fish and you feed them for a day, teach a person to fish and you teach them you feed them for a lifetime, right? So let's take a moment before we dive into the details here. Let's spend some time and appreciate the poetry that's going on here. So the proverb here is written in the form of a parallel comparative structure, right? So it's like basically something is not as good as something else. So you're comparing two things and like saying one is better than the other. So if you look closely, even if you don't read Chinese, you may notice that the only difference between the two clauses you're comparing is in the last character. The first character on the left meaning a fish, and the last character at the end meaning two fish, right? So the whole thing together is giving a person a fish is not as good as teaching someone to fish, right? So still with me so far? Okay, I assume your silence means yes. So this is actually there's actually a pretty cool Easter egg here. So these two characters are homophonic in both Mandarin and Cantonese, meaning that they have exactly the same pronunciation. So if you're just learning language, or if you're just hearing this saying for the first time, it probably wouldn't make a lot of sense to you because you're trying to compare two things, but the two phrases that you're comparing sounds exactly the same, right? So I guess that's basically like a pun that is lost in translation, right? So let's also look at the first character. The first character used in both clauses, as you can see, is exactly the same, but using the first position is intending to mean to give, and using in the last position is intending to mean to teach, right? It's not really a coincidence that these two concepts maps to the same underlying character in the Chinese language, because teaching is really giving out a gift in the form of a skill, right? So the best thing a teacher could teach is the meta skill of self-learning, or which is a gift that teaches, which is the gift that feeds the person for a lifetime. Hence the saying, give a person a fish, you feed them for a day, and teach a person to fish, and you feed them for a lifetime. So all of these are pretty not controversial, right? Like I think if you talk to any educator, any person that's trying to learn anything, they will probably agree that this is ultimately what they're trying to accomplish. However, in our 21st century economy today, things are actually a little bit tricky here. As it turns out, most of us are not actually farming or fishing, right? So what does that exactly mean for us to teach someone to fish, right? In tech, the line is even more blurry. So let's say we try to teach someone to build Rails applications today. Like, is that teaching them to fish, or is that giving them a fish that will perish in a few years when the technology go out of fashion, right? What about teaching programming, right? Like I think a lot of cities have announced plans to add more programming parts into their high school curriculums. I think even including Vancouver. Is that kind of education giving a person a fish, or is that teaching them to fish, right? So how do we apply that in the context that we're in today? So a couple of years ago, I went to RailsConf and saw a keynote from DHH, who, if you don't know, is the inventor of Ruby on Rails. So he gave a keynote there describing our job as software writers, which is pretty interesting because that's in contrast with a lot of times you think of programming as like, oh, we're like computer scientists or a software engineer, right? So he's like the point of his keynote, which you can watch on the internet, is really to counter that, right? Like actually no, like maybe sometimes sometimes you're doing like hardcore engineering science work, but most of the time you're actually, you're more like a writer, as in like writers who write books and stuff, right? Like most of the time you're trying to write code for other humans to read, right? Like you're trying to communicate with other humans instead of communicating with the computer. If like your only job is to communicate with the computer, then like there are a lot of ways to accomplish that, and we wouldn't spend so much time inventing new programming language paradigms and stuff like that, right? Like the only reason why any of that matters is at the end of the day, you need other humans to understand what you're trying to doing. So that's why his talk is framing our job primarily as writers, software writers. So I think by that standard, my computer science is anyone from SFU here? Okay, a few of you. Okay. Good, I don't have to worry about offending anyone. But like, no, like not intending to be offensive, but I think if we go with what DHX said, then I think by that standard, my computer science education at SFU is actually pretty terrible. During my 4 years at SFU, I was never really ever once graded on the clarity of my code, right? Like I was never actually given any feedback on the quality of my program assignment. Like all they care is whether it works or not. And coming to think about it, the word refactor or unit test or test-driven development, all of those things never once came up during my 5 years in school. And like most of you, I spent most of my career so far working with web technologies, like building web applications and stuff like that. And my day job involved writing like Ruby, JavaScript, working with browsers, optimizing SQL statements and stuff like that. And I think I didn't actually learn any of those things from school, right? Like I didn't learn any of those skills at my CS degree. I didn't learn Ruby. I didn't learn writing tests. I didn't learn scaling servers. So I had to pick up on all of those things on my own time, just like almost everyone here. And so come to think about it, I didn't even do that much programming at school to begin with. Most of my assignments and most of my tests are really like any other subjects or like any other science subjects, a lot of time you just get a sheet of paper with some questions on it, you write down your answers in English and you submit them, right? Like most of my assignments aren't even programming assignments. So judging my education on those criteria on like being a good software writer, being a good communicator with other people, or even being a good programmer, knowing how to use Ruby, use JavaScript, work with browser, and that. It seems like my computer science education completely misses the mark there. So it's like not only did they not teach me how to fish in school, right? Like all we did was we sat in a room and we were like theorizing, given all of these different ways that people fish, can we mathematically prove that one of them is more efficient than the other or something like that? So, I think so that I think there is an interesting question there, right? Like it's like maybe the critics are right, and like maybe my computer science education was not actually worth my time, and maybe like I shouldn't have done that to begin with. So we'll come back to that in a minute. But for now, let's look at this quote. As it turns out, computer science is not even really about programming. So this is a quote from a famous computer scientist, Dijkstra, or at least people like to attribute this quote to him. So computer science is no more about computers, and astronomy is about telescopes. So the analogy is like the computers is actually really just the tool you use to accomplish some bigger task, just like like being an astronomist is not really about knowing how to operate the telescope. So yeah, so so now we have learned that I didn't learn anything useful in or at least I didn't learn anything practical in school in my computer science degree, right? Like, and we learned that computer science is not actually about programming. So does that mean that the critics were right and I just like wasted a lot of time? Well, so I can't I would probably tell you that's probably an opinion that some people have, right? Like a lot of people feel like they wasted time going to CS and like they didn't really need any of that at their work at all. But I can't speak for everyone, but I personally really got, I spent the time doing my CS degree, right? Like first of all, I happened to really enjoy learning about the topics they covered. So if nothing else, it was fun for me. So I had a lot of fun there, like spent 4 years doing things I like, not a big deal. But I do think there's more to it than just like being intellectually interesting to me. Somehow I'm pretty sure I wouldn't be able to work on the stuff I do today at work or outside work in open source without my CS background, or at least it would have taken me much longer time to get there. I think there's some there's something that's pretty magical about the experience I went through. And I think by going through that experience, something in that 4 years, something in the 4 and 5 years really changed the way I think and the way I learn, and in ways that really helped me later on in my career. And I think, and going back to our analogy at the beginning, I think during my 4 years or 5 years in school, somehow I have taught myself the magical skill of fishing that we saw in the analogy at the beginning. Now, I'm certainly not saying a CS degree is the only way to acquire this magical skill of fishing. As I mentioned, like I have a lot of colleagues, friends, coworkers who didn't go through the same experience, and they've like accomplished a lot more things that I can only ever hope to get close to, right? But on the other hand, I have also, oh yes, on the other hand, I've also seen a lot of my friends at school or other CS students who went through the same 4 and 5 years experience with a CS degree, and they somehow they had to struggle a lot when transitioning into industry work for the reason I described earlier, because you didn't actually learn any of the things you need at school, right? So it's a huge gap. So on one hand, like you can definitely be very successful with a CS degree. On the other hand, there are also people I know who went through the same exercise and didn't really get much of it. And then here I am in the middle, feeling like, yeah, I guess they're right. Like the things I learned didn't really connect, but at the same time, there's something magical here. So now I think since I personally found that very helpful, I thought I would talk about the experience a little bit and try to see if we can distill it down to the essence of like how I actually learned the magical skill of fishing from that experience. And if we can figure it out, whoa, sorry, this thing just disconnected. I think if we can figure it out there, I think that would be pretty useful for everybody, whether you are planning to do the CS thing or whether you're planning to do the CAP thing. So this is, yeah, that's what we're gonna do today. So let's see. So to start answering the question, let's try to figure out what makes computer science a science. And in order to do that, we probably have to understand what science means to begin with. So perhaps a lot of us have the misconception that being a scientist basically means you lock yourself in the lab all day and then like you basically just do experiments, right? So while that is indeed part of the job of a scientist, if that's all you do, you're just a lab tech, right? Like you're not a scientist. So if you think about it, like doing the experiments that scientists do is really just a means to an end, right? Like the real job of scientists is to come up with like hypotheses, and the experiment is the way that they verify whether they were right or wrong, right? Like at the end of the day, like all you're interested in is whether like what can we learn out of the experiments? Like what are the hypotheses, whether they're right or not? And so the most important job is not actually doing the experiments, although that's how you learn. The most important job is to turn the results that you got from the experiments into scientific models, right? So the point of these scientific models is basically to give us a somewhat simplified view into the very complex universe that we live in. So that our tiny human brains you saw at the beginning can like even begin to understand it, right? And in other words, you're basically trying to identify useful patterns and things you can use to make predictions about the world. And these basic models, like from something as simple as the toy models you learn in high school, even elementary school, that's like those are basically the building blocks they use to build up like bigger and bigger theory to like pretty crazy things like relativity, right? So now that we have figured out what scientists actually do, we can compare scientists to computer scientists and see if there's anything similar there. And surprisingly, computer scientists pretty much do exactly the same job, right? Just like the problems we have in the physical world and the universe, most interesting computation problems are pretty complicated, right? Like probably way too complicated for us to reason about it, for us to think about it, right? So, as a computer scientist, your job is basically to distill these very complex and very messy problems in the real world and try to turn them into simplified models that we can actually implement in the computer or like at least reason about them in my head, right? So for example, let's take machine learning, for example, right? Like one of the most popular approach used in machine learning is called artificial neural network. So artificial neural network is basically, as the name implies, it takes some inspirations from the biological world, right? Like, so you look at how neurons in like, you know, in a bug or something, like look at how they actually work, and it's like, oh, that's pretty useful, that's pretty interesting. So you like simplify that into something you can implement in a computer, and somehow by doing that, you can solve a lot of like very crazy problem to like from you know, spam filters to the to the Google art and culture thing we saw in the beginning that took my picture and compared to like all the pictures in all the museums ever and find like your best match for you, right? So like of course, we're not here to talk about machine learning today. So like we can save the details for another talk, but hopefully that gives you a taste of what makes computer science science, right? Like it's basically you observe in the world that, oh, like, you know, like there's something interesting in these, in a way that these living things, living organisms think, and maybe we can get some inspiration from that and do useful things. So that's all pretty cool, but again, as web developers, which is true for most of us, unless your job involves like implementing spam filters or like image recognition every day, that's probably not, you probably won't exactly describe your job, your day-to-day job as building models, right? So how does the scientific training in the CS curriculum actually help with our jobs, like as iOS developers, as web developers, or like as game developers? How does that actually connect? Now, I will take a sip of water. Right, so, yeah, so again, the question is like how, like that's like building models, that's pretty cool. And like I can see how as, you know, as a computer scientist, your job is to build models, cool. But how does that apply to me? So I would argue that when we're programming, even though you might not feel like it, we're probably, we're still building some kind of models here, like a specific kind of model called mental models, right? So there's another name for this concept that might be more familiar to some of you, which is abstractions. When it load up, here we go. So if you're not familiar with it, I would define this for you myself, but there's actually, there's another computer scientist that summed this up much more eloquently than I could possibly do myself. So I would just read the quote for you. The essence of abstractions is to preserve information that is relevant in a given context, and basically forgetting or hide information that is irrelevant in that context. So just like in the physical world, like just like in the universe, a lot of times we as programmers or software writers, whatever you want to call it, are like, we're often dealing with some very complex systems that are way too much to fit inside our head. And let's take building web applications, for example, which a lot of you are probably familiar with. You might think, oh, like, okay, web development is like the easy kind of programming, and like I'm not doing hardcore stuff like operating system and stuff. But if you really think about it, this like web development thing, what are we actually trying to do? Well, it turns out, for a starter, you're writing code that get executed on a lot of machines across like different networks and stuff. So, and you have, a lot of times you have no control over the machines, right? Like, especially if you're writing JavaScript, like you're probably sending that code to people's browser and it's like running on an untrusted device. A lot of times you're even dealing with like unreliable network and like on underpowered smartphones and like in you know, developing countries and that. So, and whoa, sorry, this thing disconnected again. I'll just fix it here quickly. Sorry about that. There we go. And we're back. So, right, so while you might be doing the easy kind of program that is web development, if you really think about it, you're really dealing with like a soft real-time system across, and you know, like you're writing code that runs on untrusted devices across unreliable network in a soft real-time system where you have to, you know, give a response every 16 milliseconds to do the 60 frame per second thing. So that's actually pretty complicated. So next time someone tells you web development is an easy kind of programming, you can tell them that. But of course, you don't actually have to think about that all the time, right? Like if you apply for code school, they don't tell you that they're teaching you how to build soft real-time distributed system running on untrusted devices across network boundaries, right? Like that's not usually what you have in mind when you're like thinking as a web developer. So I think that's really the benefits of, that's really the power and the value of abstractions, right? It allows you to hide away the complexity behind a simple model, something as simple as Rails generates scaffold or whatever, right? And so the next person down the chain wouldn't have to worry about any of the complexity that is behind the scene. So as programmers, I think our job is basically more than just typing code into a computer, right? Like I think we're all at some level, we're all operators and builders of abstractions. And our job is basically to build useful models for other people to consume. Sometimes that means that you're writing a library and other people have to use the library, so you need to do a good job hiding the complexity and exposing a useful interface for them. Sometimes you're just writing code for your coworkers or for even for yourself in a month to understand, right? But it is no matter what you're doing, you're writing abstractions at different level, bigger or smaller abstractions. You're basically trying to, at the end of the day, what you're trying to do is you're trying to understand what you're trying to implement and try to convey a simplified mental model to the next person who is down the chain. And because we're always building on a big pile of abstractions, you probably want to be at least be aware of what are the abstractions that you're building on top, right? So in my opinion, this is where the bottom-up approach of the CS degree really shines. If you look at the curriculum of a traditional CS program, it would probably look something like this, where you, in the first year, you have you learn some basic programming, you learn some computer architecture, like how CPUs work, you learn some math, and you learn some calculus, and so on. And then on the second year, you learn some data structure algorithms, and maybe you learn some stats and linear algebra. And once you have these foundations in place, the third year, you probably learn some operating system stuff, some database, AI, maybe graphics. And in your fourth year, you can graduate to an even higher level. So you're now talking about networking, information system, computer vision, animations, and stuff like that. So as you can see, you have, because you have a few years to spend in this path, right? There are plenty of time to get a good understanding of each of the abstraction layer from the ground up, right? Like you literally learn how to build a CPU from or how to theoretically build a CPU from logic gates and stuff, right? So when something like meltdown happened, you're like, oh, okay, now I can see what this whole security thing is about. You have because each of them are roughly a year, so you have a lot of time to really get your hands dirty and really understand what you're talking about before moving up to the next layer. Which also help you to understand the connection between the layers, right? And at the same time, it also exposes you to the breadth of all the problems that we as an industry tried to solve in the past, which is, even though a lot of time you're not directly solving these problems again, knowing that they are there, knowing that they're there and knowing that your operating system or your library, your framework is handling these kind of problems for you, probably help you at least avoid reinventing the wheel. And a lot of times, there are some transferable lessons to be learned from here as well. For example, if you learn about networking, you probably learn about a pretty important pattern called finite state machines, which you can take to, oh, now I'm working on e-commerce and I can model my shopping cart the same way. And so having all of these tools under your belt allow you to basically pattern match new problems that you encounter onto these existing problems, so you can basically pull up these known solutions for problems whenever you see them. On the other hand, while these knowledge is pretty nice to have, it's pretty nice to be able to say, oh, I sort of remember understanding the CPU thing so I can kind of read the meltdown website to understand what's happening. There's a big problem with this. Since there's so many different topics to cover, and I'm not even showing that many of them, this is just a very small slice of the whole CS curriculum, and you only have 3-4 years in school, right? So that's basically not nearly enough time to cover everything, and so you have to make some trade-offs here. And the trade-off they usually make for a traditional CS degree is that you will, they want you to be really grounded, so you're gonna like spend a lot of time learning the fundamentals and build your way up. But as soon as you start working in the real world, you realize that actually no one actually built from that layer. Everyone builds on like 50 layers above that. And so suddenly you realize what you learn in school is like a laughably short stack. And there's so many things missing in between that you have no idea about. And as like the last thing you learn in school is information system, like how, in theory, how would you organize and structure a thing that vaguely resemble like Amazon, for example. But now you're in the real world, you're actually building Amazon. How do you do it, right? Since we're so used to building up from the bottom in baby steps, a lot of, yes, since we're so used to building up from the bottom in baby steps, and a lot of times we spend months or even years understanding them before we feel comfortable moving up to the next layer, suddenly having to jump like 50 layers between like the 4th year in school to your 1st year at work could be too much for a lot of people. And therefore, a lot of CS graduates basically fall off this CS cliff here where you have like 50 stories of stuff that you're missing that you never learn about. And I think this is basically where the new wave education programs like Code School really shines, right? The observation is that, well, since no one actually built from those layers anyway, why don't we just teach people from the 50th level up? So all we're going to worry about is we will teach the high-level abstractions that you actually use in your job, and not worry about any of those things in the bottom. So as a trade-off, you can now teach everything you need to know for your job pretty quickly, right? Like in a couple of months or like maybe in a half a year, you can basically learn enough of web development to be a useful Rails engineer in a startup. So, and I think for the most part, that is actually a great idea, right? Like I can say this with certainty because our company have in the past and currently hired some graduates from various boot camps across America, and we're pretty happy with the result. But so while there are a lot of advantages about focusing on the high-level abstractions, there are also some pretty notable downside to starting from up there. So, and so there is, as much as I talk about abstractions and as much as I talk about how great abstractions are, there's a big problem with abstractions that you might have heard of, which is all abstractions leak. Now, I would like to begin by saying that this is not necessarily a bad thing, right? Like there's nothing wrong with the idea of abstraction in itself. In fact, when we're like, if you remember earlier, we were drawing a parallel between science and computer science. In science, they have a similar slogan that that is basically talking about the same thing. And the way they put it is all models are wrong. However, you can observe that even though everyone knows that all models are wrong, that didn't actually stop scientists from building models, right? Like, in fact, this was not actually the end of the saying. This is not actually the point of the saying. The key insight from the saying actually come from the second part, which is, there we go, all models are wrong, but some are useful, right? And I think abstractions are basically exactly the same thing. Even though, so even though models are supposed to be simplifications, and a lot of times they're wrong, so to speak, but the whole point of these models are to omit certain unimportant details to help you focus on the right thing. So However, whether something is the right thing to focus on is, of course, highly dependent on the actual problem that you're trying to solve right now, right? So if you're learning physics in high school, it's probably pretty important for you to ignore things like, I don't know, like make all kind of simplification, like you can ignore friction, for example, right? And that's great because it allows you to focus on the big picture and learning about how things actually interact. But at the same time, if you're designing a rocket and you try to ignore friction, you probably have a pretty bad time. So part of the job of scientists is basically to understand the limitations and the boundaries of these models that you're working with and know when to switch to a different model that is switch to a higher fidelity model, right? And I think abstractions, because abstractions are just like mental models, they're exactly the same. So as people say, abstractions leak, and they're not wrong, but the key insight is abstractions leak, but somewhere useful. So when used correctly, you can, these abstractions like Rails or like libraries you use, operating systems, or even CPUs, as we learned recently, they can spare you from the distracting details, freeing up your very limited cognitive capacity or very limited mental space you have in your head to help you get things done more quickly. However, occasionally, but inevitably, something is going to leak out from the layer underneath you from time to time. So what happens when the details that Rails is hiding from you, what happens if the implementation details of the library you're using is becoming relevant to your task at hand? Like what if the abstraction is behaving in ways that you didn't expect, right? Well, that's called debugging, and if you have been programming for a while, that should sound pretty familiar. A core part of the every developer's day-to-day life is basically debugging, right? Like I probably spend 80% of my time debugging these days. And a lot of times, in order to fix the problems, you really have to pry open the abstraction boundary and go one level deeper in order to understand the details that is hiding from you. And if you get into the habit of treating all of these abstractions that you're using as opaque, like little black boxes that you can never open up, then you'll probably end up building around them in a lot of times and building this awkward contraption that eventually collapses on you. And so, for example, if you're building a web application, like if you're using Rails, because we're in a Ruby meetup, like if you're using Rails and you're using Active Record, and suddenly you have some very slow queries in your app, like your app is very slow. So to understand why your queries are slow, you probably at least need a basic mental model of how databases work in order to understand how you can structure your data or how you can reorganize your data in a way that would make it much more efficient for a database to find the answers for you. So in my opinion, like I think at the end of the day, the ability to pop up and down the stack of abstraction is as needed is precisely the skill you need in order to survive in our industry. And I would like to argue that the skill of phishing, the magical skill of phishing that like now we're coming back full circle, the magical skill of phishing that we talked about at the beginning is basically the ability to think abstractly, right? Like to think in terms of these little abstract black boxes, so you can, so you can build all the way up at the 50th level, but at the same time understanding like these the utility and the pitfalls of these abstractions, so that you can know what to do when they inevitably leak. And for me, the structure of the CS education, like the CS curriculum, the way we build up from layer on top of another layer in like a relatively long period of time, that really helped me pick up that skill of navigating the stack of abstractions. By building up from the bottom one piece at a time, it really helped me to understand the boundaries of these abstractions and how everything fit together to form bigger pieces like like Rails or the application that you're working on at work. And throughout the journey, I was constantly exposed to very hard problems and very hard topics that seem unapproachable and approachable at the beginning, right? So for example, we'll go take a course on compilers and like, holy crap, this is like really crazy. And I don't know how I'm gonna do this, but yet all the classes always follow the same pattern. We'll start with some pretty basic theories at the beginning, and then eventually somehow when you progress through the class, at the end of the day, you realize, oh, like I see how dots connect and how this very simple thing we learned from the beginning now helped me build like this thing called a compiler. That's pretty cool. And by doing this over and over and over again, like many times in the 4 years, it gave me a pretty good mental framework to on how to learn and how to keep learning up the stack, right? Beyond the point where we stop in the 4-year boundary. And that in turn gave me the confidence I needed to believe that when I encounter a new problem, I would be able to dig in to the underneath, like the abstraction that sits underneath me, and knowing that if I like dig deep enough, I will eventually understand it. It's all, computer is all deterministic. It's not like, you know, there's not any crazy magic happening there. So while I do personally think the traditional CS curriculum has an edge there in terms of like helping you understand the boundaries and like helping you navigate the stack of abstraction, I don't think it's really intrinsically require a university degree to have that skill, right? At the end of the day, there's so much to learn out there. As you can see, I didn't even fit it all on the same slide. So whether it's 4 years in school or whether it is 6 months in a boot camp, that's basically not enough time to really learn anything, and let alone not enough time to learn everything you would possibly need at your job, right? So at the end of the day, it's not the knowledge, it's not what you learn in school that will save you from the trouble you have in work. So in the spirit of teaching students to fish, I think the primary purpose of any tech education, whether you're boot camp, whether you're computer science degree, we should be focused on teaching the framework of learning, which is the skill of researching and understanding an unfamiliar technical topic. And like I think in a traditional 4-year program, you basically have 4 years to come to that realization. Admittedly, a lot of people spend that 4 years and not come to that realization. But if you get lucky and if you realize that's what's happening, then like you come away from the 4-year program having this framework of understanding how to learn things. But because in code school you have a much shorter time frame, students don't really have the luxury of like, you know, repeating the same thing over and over again and hopefully come to that realization. It becomes more important to like teach this learning framework, this mental framework more directly and more efficiently in the 6 months that we have in the bootcamp. And I think ultimately by taking a shortcut upfront, we're really making the bet that it's more efficient for the students to learn what they need on the job, and rather than spending 4 years learning most of the things that they wouldn't need on the job, right? So, and to accomplish that, we're really replacing the created learning experience we have in college, and replacing it with a lot of self-learning and workplace training, which is cool if you're highly motivated. This is probably the right trade-off, and like that is true for a lot of people that I know. However, not everyone is like that, and so once you left the boot camps training, then you're once you left the boot camp support network, it requires a lot of dedication and discipline to keep learning, and like it requires a lot of support from the community, from work and stuff. And so, and as a beginner, it's often not very clear that what you should be learning next, right? Like, so in school, whether you're in boot camp or university, you basically have someone to tell you like, okay, here's what you should learn next. But that's not super clear once you exited the, once you left school, right? So whether you're in university or you're in boot camp, like once you exited the boundary of the created curriculum, you have the problem of like, how do I keep leveling up, right? And at the same time, a lot of workplaces are not really equipped today to mentor and provide the training that and support that is really needed. So I think whether you like it or not, the shift is happening, right? So therefore, I think as we embrace these kind of new wave education program, it's probably important that we know about the trade-offs that we're making and talk about them, so that we can start having these conversations about how we can more, as an industry, more efficiently adapt to the need of these new education program that we can yeah, basically help the students level up within the workplace, within the community, and such. And I think if you had the privilege of doing a CS degree in school, I think, and if you found that experience useful to you, you should probably start thinking about what we could do to help make those knowledge accessible outside of the traditional classroom setting. Because again, like it or not, I think a lot of new entrants to the industry will not have that same experience. So it's probably becoming more important for us to somehow spread this knowledge around. And so we are getting pretty close to 8 o'clock. So let's skip to the last part. Do this. All right. So before we end, I would like to end. Before we end, I would like to close this off on a little bit of more personal and more positive note. So as they say, it takes a village to raise a child, right? Like, so if this is definitely true in my experience. When what I talked about in terms of my own experience in this talk is really just a tiny piece of the puzzle, right? Like I think, so as I said, I don't think I think I wouldn't be here doing what I do today without my education, but that's not the only part that matters, right? Like along the way, I had a few internship opportunities, and like I think a lot of people really took a lot of risk on me before I had anything to prove to them, right? And without these opportunities in the real world, I think I would personally have very likely fallen off that very big CS cliff that we saw earlier. And also my education, my CS education didn't actually end at SFU, right? Like during my last year in school, I was able to attend RailsCon for the first time, thanks to the opportunity scholarship that they were doing at the time. And that experience really opened my eyes in a lot of ways and unlocked many opportunities for me. It connected me with other people who are working on Rails, working on open source. I saw that like what people were doing with Rails in the real world and got me really excited. And all of that was only possible because I got the scholarship to go to RailsCon, right? And later on in my career, I also became a pretty active open source contributor, and during which a lot of my open source mentors have invested a lot of their personal time outside of work to help me level up and without really expecting anything in return. And so that's like after I finished school, but at the same time, that's not all, right? Like my CS education didn't actually start at SFU either. I actually cheated a little bit. So I taught myself programming in high school before I went to SFU. So when I went to the CS classes in SFU, I was basically already ready to connect the very theoretical stuff they teach at school with the very messy real world programming things that you do. And I think that really gave me an edge there. And all of that started when I had my first mentor in elementary school, actually. My computer teacher at my elementary school who would spend time outside of the school curriculum, teach me how to build websites and stuff. And like, you know, like during the early 2000s when the internet was becoming a thing with Dreamweaver and stuff. So that's elementary school, but it goes even further back, right? Like I think to be to like the first little bit of my CS education probably started when I was a kid, when I decided to, well, it would be, you know what would be really cool? It would be really cool if I tried like dragging this like Windows folder into the recycle bin and see like what happens if you delete everything, right? And instead of getting yelled at, my uncle basically came over and showed me how to reinstall Windows on a computer so I can do the same thing over and over again. And so I think that's not all either, right? Like as much as it is about what the help I got along the way is also about what I didn't encounter along the way. So for example, I don't think I would be able to do any of these without a supportive family that really encouraged me to explore my interest in programming instead of yelling at me when I broke the computer. And I, I think I wouldn't be able to do any of these if I was in an environment where I would be bullied as a geek at school, right? And I probably wouldn't have, I probably would have given up a long time ago if I grew up as a girl and repeatedly was discouraged by society from doing programming or computer things, right? So I think like as much as I talk about my education, or like as much as I talk about how my education relate to my work, I think it really is true that it takes a village to raise a child, and it's certainly no less true in the 21st century fishing village that we're talking about here. So I think I would like to end off with this. Like, I think we're all in this together, whether you're directly involved as a mentor at work or whether you're just someone who write blog posts and stuff. I think, yeah, or whether you're just like speaking at Ruby meetups and sharing your knowledge or the problems you encounter at work. I think we all have some roles to play here as we shift away from we shift into this new model of education. So if you're here today, it probably means that you have at least made it into a village somehow, which probably means you have something to give back. So I want to end it with this: pay it forward, be the village. Thank you very much.
Thanks very much, Godfrey. Are there any questions? You can pass the mic around. Or... Yeah.
Hey, Godfrey, thanks for the talk, and thanks for getting me addicted to trying to contribute to open source. I don't know if you remember that, but I hope I'm not putting you on the spot, but concrete advice, if someone here is looking for what they should do in terms of how to get into programming, or somebody's, you know, wondering what to tell their daughter or son how to get into programming, what would you say?
So that is a very big question. Sorry, so your question is really about like if like teaching little kids, right? Like, or right. You know what? I can only tell you what I personally did. Like, I don't know that I have a lot of answers. I think there's like deliberately not a lot of answers in the talk because I don't know them. For me, I guess like basically, what really attracted me is basically the ability to build things in a computer and have it do seeing it work, right? Like, I think like I started off with building websites at the time. I don't know that there's a like formula to follow, right? But I think like maybe the equivalent today is like building stuff in Minecraft or something and seeing it do cool things. But I think like I personally am a pretty visual learner, so like being able to you know, type code into like Dreamweaver and see it show up as like a page in a browser was pretty cool to me. And I think once I start there, I started like, oh, now like I actually wanted to like, you know, I want to have a button and have it do things, right? Like, so now that's the part where got into programming, and then I personally started with reading books. I don't know if kids read these days, but like, yeah. I think you have a lot more you have more tools at your disposal these days, right? Like you can, if they like robots, you can build kits and like robots, and you can build like electronics and all of that, or like even programmable juries and stuff like that. So I don't know, like I think it's important that you find something that motivates you and interests you. And like for me, that was building websites and making it like work, like have the buttons work. And yeah, like you have much more options than that these days. So whatever they end up finding interesting would probably be useful.
Hey, Godfrey. There's always a topic about finding mentors. In your experience, did you go out of your way to find mentors? Did you do any certain activities to find mentors?
Right. So I think at different stages, like I had different experience there. Like I think at very, very early on, I definitely just got lucky. I hung out with the right crowd, and I kind of was like in the right group. So I got into the class of like building websites and stuff, right? Like later on, I think it's more about basically hanging out in the in meetups and stuff where like there are other people who are doing similar things, and I would so Cal and I actually used to work together, and we had dinner yesterday, so I would actually steal this advice from Cal yesterday. So I think yesterday Cal was saying like to it's really good to hang out with people or find mentors that is like one step ahead of what you're doing, right? Like I thought that was pretty insightful when I heard that yesterday. So for example, if you ask me how to, so you're asking me how I would get into programming, I don't actually have any answers for you because that was so long ago for me, right? But for example, if you ask, like I'm learning Rust right now, so if you ask me like, oh, how would I learn Rust? I probably have a lot of answers for you. So I think I didn't do it consciously a lot of times back then, but I think now that I think about it, a lot of times what ended up working is basically end up working or hang out with people who just learned the thing that I was about to do, like maybe a couple of years ago, right? Like they're now getting into they're starting to become an expert in that sort of field. So for example, I would, one of the things that really helped me the most was when I was interning at Microsoft. When I was in Seattle, I basically went to the Seattle RB group, and that was like where Aaron Pessin, Tanner Love, if you know him, and I think Dr. Brian basically that was the early days where they were just starting out, and they were doing a lot of cool stuff. Like they were making these gems that people used very early on in the Ruby days, and that experience was pretty important to me for like learning how to write libraries, because they were doing a lot of those things back then. They were writing a lot of new libraries, so it's like, oh, that's what it did. Like, and okay, now I saw that it's not actually that complicated. I can do that myself too. So so yeah, I don't know if it's okay that I answer your question with an answer you gave me yesterday, but I thought that was a pretty good answer.
All right, if there aren't any more questions, thanks very much. Thanks again.
Oh,
one more.
Hey, so I'm glad that I came here and you gave me the term, the CS cliff. I'm going through that right now. So I just asked, do you have any advice on navigating, not falling off the CS cliff?
Right.
Hard?
Yeah, I would say it's hard. So again, like following the same pattern, I'm probably not the best pattern. Like I'm probably not the best person to answer that question, because what I did was like I basically do the two things in parallel, right? Like so when I was going through the CS classes, I was already doing a lot of like Ruby and stuff. So as I learned about databases, I was like, oh, like that thing that I did yesterday at home when I did the Ruby like Rails app, like talk to database, blah, blah. Oh, that's like the thing that I'm learning today. So that was really good. So if you can time travel, I would highly recommend doing that at the same time. And I wish CS programs are more like that, like where you do the hands-on thing and the theoretic coding at the same time. But I think for things that I'm learning right now, basically what really helped me is like, I don't know if like, are you working in the industry right now? Yeah, so I think I was also, well, as I keep saying at the end, like I think I got pretty lucky in a lot of ways. Like I think what really helped me was in my first job, I had the opportunity I needed to well, A, get the job done, but at the same time also explore a lot of these things that I'm interested in. Like, so at that time, I was interested in learning to become an open source contributor. So like I got a lot of help within the company to like, oh, this is the thing that we're doing. If I want to make it, like if I want to make it a library, open source library, that's totally cool. And I can spend time doing that. And so I think having the concrete problems that I'm solving at work really helped me to like realize the goals that I have in mind. That's very abstract. Like basically, if I just had the goal of like I want to make some open source libraries, like I probably wouldn't know even where to start with that. Like I know the technical steps to like create a library, but I don't know what I would write, right? So like being able to find opportunities at work where I have a concrete problem to solve really helped me there. And I think the same is basically true for me later on as well. Like I think the reason I became very active in contributing to Rails is like a lot of times I basically work on a lot of Rails apps at the time at Brewhouse, right? Like, and a lot of times I would find that like, oh, like why is this thing not working the way we expected? So we'll spend like, and we had pretty good clients that would be okay with us spending time, you know, like going to the bottom to figure out why is this not working the way expected. And a lot of times those would be bugs in Rails itself, right? Like, so I basically, from there, I have my motivation to actually fix a bug that I encounter in the real world instead of just abstractly thinking, oh, I want to contribute to Rails, how would I do that? So yeah, I think for me, having like concrete grounded real world problems to solve is a like good way for me to motivate myself. If you're lucky enough that you enjoy the kind of problems you encounter at work, like I think maybe trying to learn things that's adjacent to the kind of problems that you're solving at work would be helpful.
All right, going once, going twice. Sold to the Godfrey Chan. Thanks very much.
Thank you.